Do you recall scientific notation? We're going to do a quick review. Remember that it is a shorthand way of writing very large or very small numbers. For example, 3.0 times 10 to the 8th would be a very large number, whereas 2.51 times 10 to the negative 7th would be a very small number. Scientific notation is defined as a number in the form c times 10 to the nth power, where 1 is less than or equal to c, which is less than 10, and n is an integer. So in other words, we have a number that's between 1 and 10, so a single-digit number, that's multiplied by a power of 10 raised to an integer, so some negative or positive whole value. To transfer numbers from decimal notation, or your normal everyday number, to scientific notation, we need to take the decimal from its current position and move it so that it is to the right of one single non-zero number. The number of places we move the decimal will give us the exponent on the power of 10. If we move the decimal to the left, so we started with a very large number, we'll use a positive exponent. If we move the decimal to the right, so we started with a very small number, then we would use a negative exponent. So for the first example, remember that if we had written the decimal, it would be all the way in the very back. So to place this into scientific notation, I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places, so that it ends up behind the 4. So I have one single digit between 1 and 10, that's not 0. To the left of the decimal, I have to keep all of my non-zero digits. I can drop the ending zeros and say times 10 to the 9th power, because I moved the decimal 9 places to the left. And so if I were to translate this back, this would then move the decimal 9 places to the right, because that's what multiplying by 10 does. It moves the decimal. On to the second example, we see the decimal right here, and I need to move it all the way over so it's behind the 6, right between the 6 and the 7, because I need one number that's not 0 to the left of it. So that's going to be 1, 2, 3, 4, 5, 6, 7 places. So I will have 6.7 times 10 to the negative 7th power. I use a negative exponent this time because I'm starting with a very small number and I'm moving the decimal to the right, so that if I was going to translate 6.7 times 10 to the negative 7th back into a regular number, the negative sign tells me to move it to the left, and that this is going to be a very small value. So, next example, a really big number, the decimal would be here if we had written it, so I can put it in, and then I need to move it 1, 2, 3, 4, 5, 6 places, so it's right behind the 5. So we'll have 5.702, because I have to keep all of my non-zero digits, times 10 to the 6th power. Final example of going this direction. Here's my decimal. I need to move it so it's behind the 1. So that's going to be 4 places to the right. 1, 2, 3, 4. So I get 1.04 times 10 to the negative 4th power. And so that's how we translate from decimal notation into scientific notation. So what I'd like you to do now is to pause this video, turn your attention to the extra practice worksheet, and try a few examples of going this direction, going from decimal notation to scientific notation. Once you've done all of the examples of that form, come on back and we'll remind you about how to move from scientific notation back into decimal notation. Okay, so let's imagine we want to go the opposite direction. To place a number in decimal notation, we move the decimal the same number of places as the exponent on the power of 10. If the exponent is positive, we move the decimal to the right, and we should end up with a very large number. If the decimal is negative, we move the decimal to the left, and we'll end up with a very small number. Let's take a look at some examples. So we're asked to rewrite each number in decimal form. Example 5, we're given 9.332 times 10 to the 6th power. So I know because this is a positive exponent, I'm going to move the decimal to the right in the positive direction, and I'm going to end up with a very large value. So I'm going to take my decimal from here, and I'm going to move it 6 places to the right. But I can see I run out of numbers, so I'm going to add a bunch of ending zeros so that I have plenty of space in which to move my decimal. And so now I'll take my decimal and move it 6 places to the right. And so that's 1, 2, 3, 4, 5, 6. So that I will have 9, 3, 3, 2 with 3 zeros behind it. So if I insert my commas, that means I have 9,332,000. Next example says 2.78 times 10 to the negative 4th. And so this time, because the exponent is negative, I'm going to move the decimal to the left in the negative direction, and I'm going to end up with a small value. I don't have enough places to move it right now, so I'm going to add a bunch of leading zeros so I have plenty of space to move it. Because remember, zeros are placeholders. And so I take my decimal and I move it 1, 2, 3, 4 places to the left. And so I'll have 0.30278. So a very small value. The third example, 4.5 times 10 to the 5th power. So because this is a positive exponent, I'm going to move the decimal to the right, so in the positive direction. So I need some ending zeros here, so I have plenty of room to move my decimal, plenty of placeholders. And so I'm going to move it to the right 5 places. 1, 2, 3, 4, 5. So I'll have 4, 5, and 4 zeros. So I get 450,000. Okay, again, pause the video and try some of the scientific notation extra practice sheet. When you've tried all of the problems that ask you to go from scientific notation back to decimal notation, come on back and we'll take a look at how to operate when we're in scientific notation. Okay, so let's imagine we're given two different numbers written in scientific notation and they ask us to multiply or divide them. We'll first take a look at example 8 with multiplication. What we can do here is multiply the first terms, or the first part of each scientific notation number, the 2.3 times the 5.5, and then multiply the powers of 10, because multiplication is commutative, so the order in which we multiply does not matter. So let's start by taking 2.3 times 5.5. Since the multiplication problem has two decimal place values, one from this number and one from this number, we know our answer will have two place values. So I start in this column, multiply 5 times 3 and get 15, carry the 1, 5 times 2 is 10, plus 1 is 11. My placeholder, 5 times 3 is 15, carry the 1, 5 times 2 is 10, plus 1 is 11. So when I add this up, I get 1, 2, 6, 5. I need 2 decimal places, so I put my decimal here. And so I have 12.65 times 10 to the, well, when I multiply the same base, I simply add the exponents. So -1 plus 3 gives me 2. So it's 12.65 times 10 to the second power, because -1 plus 3 is positive 2. But it's not in scientific notation, or at least not proper scientific notation. I've got 2 decimal place, or 2 numbers in front of the decimal. Can't have that. I need only 1 to the left of the decimal. So I'm going to move my decimal 1 place to the left and have 1.265. And so I must increase the exponent on the power of 10 to now be 3. And so that would be our solution. We can do the same sort of thing with division. I can go ahead and divide these numbers and then take care of the powers of 10. And the reason this is working is we're using the commutative property of multiplication, so it doesn't matter in which order I do the multiplying. So let's start by taking care of the 4.2 divided by 2. So again, when we divide and we've got decimals, we move the decimal so that we have a whole value on the outside, and we'll move it the same number of places on the inside. So instead of 2.0 into 4.2, I'm going to do 20 into 42. It's going to go in 2 times to give me 40. I subtract, I get a remainder of 2. So now I need to add a decimal and bring down a 0. And add my decimal up top. 2 goes into 20 one time. So 1 times 20 is 20. Remainder of 0. So I have 2.1 times 10. When I divide the same base, I subtract exponents. So 9 minus 7 gives me 2. And so the exponent on the 10 will be a power of 2. So we get 2.1 times 10 to the second. And now I'll go back to your extra practice sheet and make sure you finish any you haven't completed yet, and then check them with the teacher.